All right, so this is the first section of chapter 4, and this is all about polynomials and kind of looking at their relationships and the graphs of them, things like that. So what I want you to do is just take a minute. I want you to pause this video, and without using your graphing calculator, I want you to try to match each of these equations right here with these graphs, okay? At first glance, it'll be tough, but you should be able to figure it out. So try to do that real quick. All right, what you should have gotten is this right here. So really, C should have been an easy one because you know that the y-intercept is at 1, so that should have given it away. You should have known that y to the 4th looks like this. It looks like y squared, except it's a little bit wider at the bottom. So that'd be here, and then some rendition of that would be here, which would be right here. Okay, you know x cubed looks like this, okay, and then if you put a negative in front of that, so negative x cubed, it would go this way. So just kind of by process of elimination, you should have gotten these. All right, so these are types of polynomials that you will need in class. So just a constant would be f of x equals a naught, or just f of x equals a number. Okay, there's no variable involved in a constant. And a constant just on a graph would just be like this, right? Linear, of course, we've done that. Quadratic, we've done that. Anytime the highest power is a 3, we call that a cubic function, and anytime the highest power is a 4, we call that a quartic function. Okay, so just know that a polynomial is a monomial or sum of monomials, so as long as each one of these terms is a monomial, we're good. Written in standard form, we write it where the exponents go in descending order, and that's kind of something we do naturally because we've always done it, but do know that that's a thing. All right, so if I look at these, I first want to find out whether each of them is a polynomial function. Okay, if so, write it in standard form, state the degree, state the type, and state the leading coefficient. So the degree, if you don't know, is the highest power. Okay, and then the leading coefficient is the coefficient or the number in front of the highest power. The type would be like we just talked about. Is it a constant? Is it a linear, quadratic, so on and so forth? And I think that's it. Okay, so if I look at this function, this yes is a polynomial, and it's already written in standard form. Okay, so notice the third power comes first, then if we think of that, that's like the first power, then no variable at all. So the degree is the highest power, which is 3, and then the leading coefficient is the number in front of the x to the third, which is -2. Don't forget that negative. That's very, very, very important. And because the highest power is 3, we would say that that is a cubic function. So that would be the type. All right, so let's look at B. All right, is this a polynomial function? Yes, it is. It is not in standard form, so we're going to write it in standard form. So the highest power is 4, so we want that written first. So we would say square root of 2 x to the 4th minus 0.8 x cubed minus 12. Okay, this is in standard form. Okay, my degree is the highest power, which is 4. Because it's 4, my type is that it's quartic. My leading coefficient is square root of 2, and that is it. All right, if I look at these last two, I'll just give it to you. Both of these are not polynomial functions. And the reason this one isn't is because we have a negative exponent. Okay, you don't have to know this now, but we'll learn this in second semester. 7x to the negative 1/2 is written as 7 over x. Which is a rational function. Okay, and then this one right here This is no because we have x as a variable, and as we will also learn in the second half of this, or second semester, this is called an exponential function. All right, these are 4 graphs that you need to understand and really know what they look like. I'm hesitant to say memorize because you shouldn't have to memorize them, you should understand them, but these are, you do have to know what these look like. Okay, so anytime we have an even function is going to be like this, okay, with a positive leading coefficient. If we have a negative leading coefficient, it's going to turn it into this, or some type of form as this. So notice we have these lumpy things in the middle. The more stuff we have going on in the equation, the more like lumps and turns that'll do, but the majority of it looks like this, okay, so this would be even function. And then the same thing with an odd function. If you have a positive leading coefficient, you'd have this. That would be a positive leading coefficient. And then, of course, if you turn that to make it negative, it would do this. And the more complicated the equation gets, the more like curvy things you have in the middle, but for the most part, it looks like this. Now, this is for any even function. So it could have a power of 2, could have a power of 4, could have a power of 28, any even function, and then this is any odd function. Could have a power of 3, 7, 29, whatever, okay? It will always have the same type of form. All right, so when we say describe the end behavior, we're wanting to know if we blow this graph up all the way to infinity, all the way around, what's happening, okay? So when I first look at this, I'm just gonna put it on graph, like not to scale by any means. Okay, I know we have an even coefficient, or sorry, an even degree and a negative coefficient. So I know my graph is going to look something like this number. Okay, now we will write this as, there's 2 parts to this. As x goes to negative infinity, comma, f of x goes to something. And then as x goes to positive infinity, comma, f of x goes to something. Okay, now what that something is, I'll explain that here in a minute. So just remember that when we're talking about f of x, we're referring to the y, right? So this is the y, this is the x. And remember, our x coordinates tell us left and right, and our y coordinates tell us up and down. Okay, so in this equation, the graph looks like this. So what this is saying is as x goes to negative infinity. So here's our x value. As x keeps going and going and going and going and going, all the way to negative infinity, we're going and going and going. Okay, what happens to my y value? When my x goes to negative infinity, my y, or my f of x, goes to, well, it's going to continue going down, 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 down. So we're going to say it goes to negative infinity. Okay, now we're going to turn our table to where as x goes to positive infinity. So we're going right, 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 right. We're going to keep going and going and going and going and going. And the further right we go, my f of x, which my up and down, continues to go down, 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 down. So this would also be negative infinity as well. Okay, I want you to try part B by yourself. What you first should do is look at the highest degree and the leading coefficient and kind of rough sketch what that might look like, and then do each part as x goes to negative infinity, as x goes to positive infinity. So go ahead and pause this and do that now. All right, so with this being odd and this being negative, I'm going to have something like this. Okay. All right, so I have 2 parts. As x goes to, let's do negative infinity first. F of x goes to, and as x goes to positive infinity, f of x goes to something. All right, so if I look at this, as x goes to negative infinity, so as I go more and more and more and more left, this graph is going to go more and more and more up. Okay, so this would be positive infinity. So as x goes to negative infinity, my f of x goes to positive infinity. Okay, and then over here is my x goes to positive infinity, so now I'm going right, 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 all the way. And as I go right, this just continues to go down, 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 down. Okay, so this would be negative infinity because you remember f of x is my y value.